This is Mongo Quant. In the last video, we have seen the simple regression like this. And today, we will learn the multi-regression like this. And the most different of this is if we have only one parameter like is x, it will be a line. But if we have two parameter x1 and x2, it will be a 3D, and then will be a plane. So let's go detail. Okay. We refer this URL, and if we want to learn the multiple regression, is the formula is this: y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon. So the x1 and x2 is my parameter. It have two. So just like before, we first import my package. Here in attention, our matplotlib version is 3.10, and if your version is old, it will be some different in your code. So let's go on. Create data. We use mesh grid, and from -15 to 15. Size x1 size is has 25, and it will x2 is also so. The sample number is 25 square. Like before, y equals this. Just use a random force to build some epsilon and simulate our raw data. And we plot it. Use this code. The orange code is this, but it cannot use. It have be deprecated. So we use this 9 and show it out like this. It's a 3D picture. Then we get x and y out. Use s.sm.ols model to build a model and fit it. Then we can get a summary. This is the OLS regression results. The number of observational is 25 square is 625. Their model is 2. It means 2 parameters, x1 and x2. Okay, we see this r square is 0.678, nearly 1800. No, nearly 80%. So it's good, and this adjusted r squares is very close to the r square, so it's no overfitting, and the probability of f statistic is very close to 0, so it's good. And finally, we can see this is our beta result. This means beta 0, beta 1, beta 2 is this. This is my result. Nearly 50, nearly 1, near 3, and the p is very close to 0, so it's good. Okay, this number is equal to this. Yes, the 15, 1, 3. Yes, 15, 1, 3 is very close. So we use formula, calculate by hand using this OLS formula. The result is also like before, 15, 1, 3. And we use model predict to get 1 hat. We plot it like this is the result of my plot. We can see it's a plane. Yes. So if we have more parameters such as 4, 5, 6, and so on, we cannot draw it on the graph if there are more than 3 parameters. This is 2 parameters, x1 and x2, and this is y. So it only have 2 parameters, but it's 3D. So if we have 4 parameters, x1 to x4, the formula is this, and we set the sample size is 10,000 and build it by random to select it. Build X, and this is my betas. Use this code to build a Y. The Y is the raw data, and then we use the raw data and the OIS model to fit it. Yes, like this. We just only use OIS model and fit it. So we get a summary. We can see that observations of numbers is 10,000 is true, is correct, and have 4 parameters is correct. Let's see this. R squares nearly 100%, and the adjusted R squares is very close. It's just equal. And the probability is very close to the 0. And the result of the probability this is nearly 0, so it's good. And the result of it that is this: 50. 1 minus 2, nearly 3 minus 4. So let's see this: 50, 50. 1 minus 2, 3 minus 4 is very close, like this. Just like before, we use the formula to manually get its result. It's very close to, yes, this and this is very close. So this is the multiple regression video. Thank you everyone. See you in the next video. Bye.